This is Gunasundari going to present Database Management System concepts from IT Department of GD Notes College. Before going into a further discussion of database, we must have a prior knowledge of exactly what is data. Data can be defined as a collection of facts and records on which we can apply reasoning or can do discussions or some calculations. The data is always easily available and is in plenty. It can be used for processing some useful information from it. Also, it can be redundant. Can be an irrelevant data can exist in the form of graphics, reports, tables, text, etc. That represents every kind of information that allow us easy retrieval, updating, analysis and output of data by systematically organized or structured repository of indexed informations. The containers of data having huge amount of data known as database. For example, a public library stores of books. Database are computer structures that save, organize and protects the delivered data. Any system that manages database is called a database management system or DBM. Inside a DB, the data is recorded in a table which is a collection of rows, columns and is indexed so that to find irrelevant information becomes an easier task. Let us move to the next topic, that is the purpose of the database system. The chapter 1 is an introduction about the purpose of a database systems, view of data, data models, data definition language, data manipulation language, transaction management and storage management. Here, the database management system is a collection of interrelated data, the set of programs to access the data. Database management system contains the information about a particular enterprise. DBMS provides an environment that is both convenient and efficient to use. Here are the examples of database applications. Bankings. All the transactions can be done by means of the banking. Online transactions are taken place in the banking enterprises. And the airlines, the reservation and the schedules can be done by means of this database management system. And the universities, registration process and the grading systems can be done in the universities. In the sales, the customer and the products and the purchase can be done in the sales. In the manufacturing, production, inventory, orders, supply chain. These all are done in the manufacturing technology. And then in the human resources, employee records, salaries, tax detection, everything can be done in the human resource department. The database touch all the aspects of our life. In early days, the database applications were built on the top of the file systems. The drawbacks of using the file systems to store data. The data redundancy and inconsistency, which means the multiple file formats, duplication of informations in different files. Difficult in accessing the data. Need to write a new program to carry out on each new task. And what is the data isolation? Data isolation is nothing but the multiple file formats or the data isolations. What is an integrity problem? So in integrity constraints, for example, the account balance is greater than 0 becomes the part of the program code that is hard to add new constraints to change the existing one. Here are the drawbacks of using the file systems. The purpose of the database system is continued here. The atomicity of updates. The failure may leave database in an inconsistent state with the partial update carried out. Example, the transfer of funds from one account to the another account should either complete or not happen at all. The concurrent access by multiple users. The concurrent access to need for performance. Uncontrolled concurrent access can lead to inconsistencies. For example, two people reading a balance update at the same time. Next one is the security problem. Then, the database systems offers solutions to all the above problems. Here are the levels of abstractions. There is a physical level, logical level, and the view level. The physical level describes how a record, for example, the customer, is stored. Logical level describes the data stored in the database and the relationship among the data. The view level, the application program hides all the data types. The view can also hide the information, that is example, salary for the security purposes. Here we are going to see the architecture of the database system at the view level, logical level, and the physical level. Instance and schemas. The schema, the logical structure of the database. Example, the database consists of information about a set of customers and accounts and the relationship between them. The analogous to the type of the information of a variable in a program. There are two types of schemas, that is a physical schema, another one is the logical schema. The physical schema is the database design at the physical level and the logical schema is the database design at the logical level. What is an instance then? The actual content of the database at a particular point in time, analogous to the value of the variable. Then next we are going to say about the physical data independence. What is the physical data independence? The physical data independence is ability to modify the physical schema without changing the logical schema. Here we are going to see about the data models. What are the different types of data models? Entity relationship model, relational model, object-oriented model, semi-structured data model. All the data models are the network model and hierarchical model. Here is the year diagram specified with the customer and the account. Customer contains the schema such as customer ID, customer name, customer street, customer city. And the account schema is the account number and the balance. Here, the account number, balance, customer ID, customer name, customer street, customer city are called as attributes. Here, the customer, depositor and account are called as the entities. Depositor is the relation between the customer and the account table. Next, we are going to say about the year model of the real world. Entities are nothing but the objects. As we seen before, the example of a customer and the account table is the year diagram as shown in the previous slide. The relationship between entities is the depositor table. Now, I am going to explain what is a relationship between the entities. For example, the account number A101 is held by the customer Johnson. The relationship's depositor associates customers with account. The widely used database design. Relational model. One of the relational model is shown above. Here, the customer ID, customer name, customer street, customer city and the account number is shown in the table. Within few of the values are inserted into the table by means of the rows. You can see the Johnson Smith and Johnson and Jones are the customer names and the customer streets are given and the customer city is given and the account number is given. Here, the customer ID, customer name, customer street, customer city and account number are the attributes. Here is the complete table of the year diagram as shown in the before slide. Here the customer ID, customer table, account table and depositor table is shown clearly. What is the data definition language? The specification notation for defining the database schema. For example, creating a table is one of the data definition language. Creating a table, how to create a table? While creating a table, by means of the name, entity name, account, we insert the attributes names as account number with the character as a data type and the balance with an integer as a data type. These are the two attributes inserted in the account table. The DDL compiler generates a set of tables stored in a data dictionary. Data dictionary contains the metadata. Metadata is nothing about the data about data. And the database schema, data storage and data definition languages. The language in which the storage structure and access methods used by the database systems are specified. Usually an extension of data definition language. Now we are going to say about the DML. What is a DML? DML is a data manipulation language. The language for accessing and manipulating the data organized by the appropriate data models. DML, also known as a query language. There are two classes of languages. One is procedural, another one is non-procedural. In procedural, the user specifies what data is required and how to get those data. In the non-procedural languages, user specifies what data is required without specifying how to get the data. The SQL is mostly widely used query languages. In SQL, the SQL widely used non-procedural languages. For example, find the names of the customer with the customer ID. How to find the name of a customer using the customer ID? For that, we are going to write a query by means of the select command. Select customer name. What's the customer? Customer is the actual entity name and the customer name is the attribute name. From the customer table, where customer ID is equal to the value specified. In this query, the customer ID of the 192.192.83.7465 is accessed by the database and the customer name is fetched from this query. For example, find the balance of all accounts held by the customer with the customer ID. In this, the account balance is fetched by means of the customer ID from the two tables. From how to get the values by means of two tables. The depositor and the account table, the values are fetched. Depositor.customer ID is equal to 192.83.7465 and the depositor dot account number is equal to the account number. What does mean by that actually is, both the account numbers of the depositor table and the account table must be equal. If the AND operator states that if it is true only by both the conditions are true. The account dot balance is displayed if only if the depositor dot account number is equal to the account dot account number. Transaction management. Transaction is a collection of operations that performs a single logical functions in a database application. Transaction management components ensures that database remains in a consistent state despite system failures and transaction failures. And that is, the transaction failures and the system failures can be made because only of the power failure and the system crashes. The concurrency control. The control manager controls the interaction among the concurrent transactions to ensure the consistency of the database. Next one is the storage manager. Storage manager is a program module that provides an interface between the low-level data stored in the database and the application programs and queries submitted to the system. The storage manager is responsible for the following tasks. What are the following tasks? Are the interaction with file manager and the efficient storing, retrieving and updation of the data. The very next slide is the overall system structure. Here we can see the overall DBMS architecture. Here the naive uses application interface for application programs, query tools, administration tools, and then the next box contains the compiler, linker, DML queries, DDL queries, and the application programming object, query evaluation engine, DML compiler and organizers, and the next one is the storage manager, which contains the buffer manager, file manager, authorization and integrity manager, transaction manager, which is situated below the query processor. And the next one is the disk storage, which contains the data, indices, data dictionary and statistical data. This is the overall system structure. The next one is the application architecture. There are two different types of architecture is given here. The two-tier architecture and the three-tier architecture. The two-tier architecture, which is the client program using the ODBC, that is Open Database Connectivity, and the JDBC, which is an Java database connectivity to communicate with the database. Next one is the three-tier architecture. Example, web-based applications and the application built using the middleware. These are the two architectures in the application architectures. One is two-tier architecture, another one is a three-tier architecture we have seen in this slide. The one part is the client, the upper part is the client, another one is the downward direction is the server, in which the server side, the application server and the database system is present in the three-tier, and the two-tier architecture, there is a database systems alone. The client side, the user and the application is in the two-tier architecture, and the user and the application side is same as in the three-tier architecture. Hope you understand the concepts and the discussed in this chapter about the DBMS concepts. Thank you.